Okay, so 8th grade, we are going to move on and we are going to do scatter plots for this unit. So a scatter plot is exactly what you think it is, and I believe that's your first vocabulary term. It is literally a graph. It's a plot where the points are all scattered about. This is just an example of one. So remember that the horizontal axis here, that's our x-axis, and the vertical is still the y-axis, okay? I don't have them labeled, but that's what they are. Notice also that I only have quadrant 1 on here because most of the time with scatter plots, you're dealing with real-world data, and most of that data is things like time and money, which can't go negative in the first place, so we just don't even bother drawing the negative part of it. So that's what a scatter plot is. Okay, now for the rest of the vocab. The next vocabulary term is bivariate data. Now, bivariate data is just a big old fancy word for your two labels, okay? In this case, it's years and oil prices. Bi means two, okay? So bivariate data is just what we have labeled the X and Y axis. So this would be a scatter plot that shows the oil prices as years go by, okay? So as the years increase, you can kind of see the oil prices for the most part. They're increasing and then they dip down and then they increase again, okay? So that's bivariate data is just what are we labeling our two things, okay? Next, I have the terms cluster and outlier together on the next board. Okay, so you have a scatter plot here. This one's different than the other two you've seen. A clustering is exactly what you think it is. When you have a cluster of people, you have a group of people together. So our clustering on this graph is right here. We have a bunch of dots that are kind of really close together, clustered together. An outlier is a point that is far away from the rest of the data. So up here is an outlier because it's way higher than the rest of the data. This could also be considered an outlier because it's a lot lower than the data. So like a real world example of an outlier is if someone was reading, if you had to report your reading minutes to a teacher, and for the most part, most of you read 100 minutes a week, you might have an outlier of someone who reads like 500 minutes a week. You know, they're really far away from the rest of the data. Or you could have an outlier of someone who reads 0. You know, they're further away from the rest of the data. And that was something we talked about last year too in 7th grade when we did mean, median, and mode. So that's a cluster and an outlier for a set of data. Okay, then our scatter plots are going to have a label for your x-axis and your y-axis because what a scatter plot does is it is comparing two units. Okay, so when I go back to this one, I am looking at what happens to oil prices as the years go up. Now, I didn't label these with numbers because I'm just sketching them to show you, but this could be the year, 1980, 1990, 2000, 2010, 2020, for example. Or it might be every 20 years, I don't know. And then these prices. But we're looking at what happens. How does the year affect the oil prices? Is there some sort of a correlation between these things? Okay. Do you see it or not? And so what you can see, though, you're going to look for what we call a positive association or positive correlation, a negative or none. So here's an example of what we call a positive association. Some people say positive correlation. Some people say a positive trend. It all means the same thing. Positive means going up. So this one, our x-axis is time spent studying. So are we seeing, does time spent studying have some sort of correlation to your test score? If you look, this is a scatter plot. Now the dots aren't as scattered as that first picture I showed you, but it's still a scatter plot because it isn't making a perfect line. But you can see for the most part, the points are going up, positive. Just like when a line goes up, it's positive. So we would say there is a positive association, a positive correlation between time spent studying and your test score. So the more time you spend studying, your test scores get higher. That's what this graph is showing. Okay. Now, I just made this up, but to really show this, I would have to get the actual data points and I would have to plot them. I'd have to ask students, okay, how much time do you spend studying? What were your average test scores? And then I would plot a point. Every point would represent a student. Now, could you have outliers for this? Absolutely. You know, every once in a while you have that person who barely studies and they somehow still manage to ace everything, right? And you have the person who studies their butt off and maybe just can't quite get that score. Or maybe this outlier is a person who, yeah, I spent hours studying, but those hours were a phone in my hand and I was checking Twitter and Instagram every 2 minutes. So are you really studying? So that's just something to think about. One of the things we have to be able to do is say, why is that outlier there? Okay. And what do we see? So this would be a positive trend. The more time you spend studying, the higher the test scores go. This is an example of a negative trend, negative association, or negative correlation, whatever word you use, they all kind of mean the same thing. Okay? And this time our x-axis is time spent on social media, and our y-axis is test scores. So this is showing a negative trend, that the more time you spend on social media leads to a lower test scores. The more time spent on social media, the lower the test scores. So someone over here who's spending like 0 hours on social media is getting higher test scores. Someone down here who's spending a lot of time on social media is maybe getting a lower test score. And so then one of the questions, if we were in the classroom doing homework, might be why? Why do you think that is? And one of the obvious answers is, well, if you're spending time on social media, you're not spending time on homework or studying or focusing on your studying. So you're not really learning the material the way you need to. Now, you might have an outlier, someone who spends a lot of time on social media and is still doing well. Why? Well, maybe that social media is a site to help you with math, you know, something along those lines, especially if you're in college. Sometimes social media helps you get to those points. Then you could have something, a scatter plot like this. This is no association. You cannot tell if those points are going up, going down, or what. And so I've labeled this one time spent studying and price of coffee. So this is showing there's absolutely no correlation between your amount of time studying and the price of coffee in the US or wherever. They are all over the place. There's no association between these two pieces of data. And that can certainly happen sometimes when you look. Okay? So that's the basis of a scatter plot. What it does is you're looking at two things and you're saying, does this one have any effect on this one? Do I see any sort of a pattern between them? Positive, negative, or the answer could be none. There's no association here. So I want you to get your vocab filled out and then you have some IXL links to work on.